guys a lot of space for these here just in case. So what we're doing today is essentially the same thing we did yesterday. Essentially the exact same thing. We're solving these rational equations. Now the first thing we're going to find on this here is the restrictions. Now there's two problems on the first page, so I wouldn't put you can put the restrictions next to it or at the bottom. It's up to you. Now where you want to list those out. Now our restrictions are going to be whatever value of x is going to make the denominator be 0. So our two places where it can be 0 is 2x and x plus 1. Well, our 2 times x, there's two ways we can go about solving it. One, anytime we have two or more things multiplied together to equal 0, one of them must be 0. So x is equal to 0. Or we can just divide both sides by 2. And it still tells us that x is 0. Now our other one, x plus 1, we would subtract 1 from both sides, telling us that whenever x is -1, we would have a denominator of 0, and that does not work either. So the two restrictions for this problem are 0 and -1. If we get either one of those as a solution, it won't work. So if we've solved it and found that, say, x is equal to 1, -1, well, we would just mark it out because it won't work. It's what we call an extraneous solution. It's a solution we get from solving, but doesn't work in the original problem. Now, our first step in solving is figuring out what we need to multiply everything by to get our fractions to simplify out. X plus 1 and 2x. Because our first rational expression, the x plus 1 and x plus 1 would cancel. The middle one, the 2 and the x would cancel. And our last one, 2x would cancel. Which leaves us with 3x times 2x. And again, we could write it out as 3x parentheses 2x. But 3x times 2x is x squared, because our 3 times 2 is 6, x times x is x squared, minus 5 times x plus 1 is equal to 3 times x plus 1. Questions on this here? So the next thing we need to do is distribute. And we're not going to multiply the x plus 1 by 5. We're multiplying it by -5. We do need to make sure we multiply by the correct sign. -5 times x is indeed -5x. And -5 times 1 is -5. Here we can distribute the 3. 3 times x is plus 3. Now we still have a quadratic term. We have that x squared term. So we need to get this equation equal to 0. Now, it doesn't matter if we move everything from the left to the right or right to the left. I always pick whichever one's going to be the least amount of steps. Because if I'm going from the left to the right, we're moving 3 things. If we're going from the right to the left, we're moving 2. So it might be easier to subtract our 3x and then 3, or 3 and then 3x. Order doesn't matter. Because if we subtract 3x from both sides, we'll have 6x squared minus 8x minus 5 is equal to 3. And then we can, giving us 6x squared minus 8x minus 8 is equal to 0. Question on any of this so far? Now at this point here, we need to solve this quadratic equation. Now we could graph it, we could factor it, we could use the quadratic formula. It doesn't matter which way we use first. So if we wanted to graph it, we can grab the graphing calculator, hit our y equals 6x squared minus 8x minus 8. Graph So there is one definite place it crosses the x-axis, and that is at 2, because we get the 0.20. So that's one of our solutions. Do we have another? No. Because the other one is probably located between -1 and 0, because we do have something called the intermediate value theorem. Because at 0, the y value is -8, it's negative. At -1, the y value is +6. It went from positive to negative. The only way the y value can go from positive to negative or negative to positive is if it crosses the x-axis, because that's where it's 0. So somewhere between 0 and -1, there is a solution. But we know one of the values is indeed 2. So since we know one of the values is an integer, R2, it is factorable. So we can go through factoring it or the quadratic formula. But before we do either, is there a greatest common factor between 6x squared, 8x, and 8? 2. And since it's a number, we can divide it out. We can get rid of the 2. And what that leaves us with is 3x squared minus 4x minus 4 is equal to 0. I'm going to go about factoring this. 2 sets of parentheses with 3 spaces. Since the third term is negative, our signs are opposite, positive, negative. Factors of 3x squared, we will have x and x. And 1 and 3, where do we want to put the 3? First x. We'll put it with the first x. Factors of 4 are 1 and 4 or 2 and 2. Do we want 1 and 4 or 2 and 2? 2 and 2. Now we can check this here. 3x times -2 is -6x. 2 times x is plus 2x. Telling us the middle term is -4x, which is the correct middle term. So these are the correct factors. Questions on how we factored it? Now at this point here, we have 2 things multiply together that equal 0, so one of them must be 0. Either 3x plus 2 is equal to 0, or x minus 2 is 0. Now for our 3x plus 2, first thing we can do is subtract 2, telling us that 3x is equal to -2. At this point here, we can divide both sides by 3, telling us x is equal to -2/3, -2/3. So there's one of our solutions. The other one we're going to add 2 to both sides, telling us x is equal to 2. Is it any surprise that we got one of the solutions as x equals 2? No, because that's what the graphing calculator told us. Now, is either one of these a restriction? No. So both of these solutions work. And that's it. Questions on this so far? We feel good with these so far. Let's look at the next one on the first page. Now this one here is a little bit different. And the thing that makes this one different is our middle term. The middle term's denominator is x squared minus 1. Is that factorable? And specifically, it's a difference of perfect squares. So how would it factor? X and x minus 1 and plus 1. Difference of perfect squares, so x minus 1 and x plus 1. So that's one of the differences between our 751 and 752. Some of the denominators actually need to be factored. Because up to this point, we've kind of glossed over it because none of them factored. Here they do. And that helps us see what the restrictions are. Because the two restrictions that we have is x plus 1 and x minus 1. Well, with our x plus 1, to see what would make it be 0, we subtract 1, saying x cannot be negative 1. With x minus 1, we would add 1, getting x equals 1, so x cannot equal 1. Now, if we wanted to, we could make this into one statement, saying x cannot equal positive or negative 1 or plus or minus 1. So if we get positive or negative 1, we know it's one of our extraneous solutions and we can throw it out. It doesn't work. Questions on this here? What do we need to multiply everything by? X minus 1 and x plus 1. And if you're not sure, because some of the ones later we do have to have some repeated ones, take it one at a time. All right, guys. So, on some of the other ones we might have to have x minus 1 or x plus 1, each of the terms more than once. And if you're not sure, go on and start with it once. Because if we look through this here, we do have 1x plus 1 in the bottom of the fraction. So it'll cancel out with our one of the x plus 1s we're multiplying. Its denominator's gone. We move to the next one. There's 1 x minus 1 in the denominator. And we multiplied it by a single x minus 1 term. We also multiplied it by x plus 1. So its denominator is completely gone. And since all the denominators factored out, we don't have to multiply by anything else. So the first expression, we have 4x plus 1 being multiplied with our x minus 1 is equal to 12. Well, x plus 1 and x minus 1 factored out completely, so it's just 12. Plus 3 times x minus 1 and x plus 1. Because it didn't have a denominator, nothing simplified out, so we're left with this here. Questions? Any questions on any of this here? Now the first thing we can do next is distribute. So we're going to do 4x times x squared. 4x times negative 1 is negative x. Negative 4x. Then we're going to do 1 times x, which is plus x, plus 1x. And 1 times negative 1 is negative 1. 12 plus 3 times. So when we do the x minus 1 times x plus 1, we'll still have our parentheses because of the 3 out front. We didn't do it with our 4x squared minus 4x plus x minus 1 because there's not a number in front of it. Now, the next thing we can do is do the exact same thing. We can distribute the x and negative 1. Good question. Didn't we get x plus 1 and x minus 1 from somewhere? It's the factors of this here, yes? So should x plus 1 times x minus 1 return back to x squared minus 1? We can distribute it out. We can do the entire distributing property, use it to simplify it down. But if they factored from x squared minus 1, they should multiply together to be x squared minus 1. Because again, it would be x squared plus x minus 1. If we already know what it multiplies to be, because that's where we got it from, might as well skip that step. Combine like terms. We have 4x squared minus 3x minus 1. 12. So we need to distribute the 3. 3 times x squared is plus 3x squared. And 3 times negative 1 is negative, yep, negative 3. We did, yes. Do we have any like terms? We do have those on opposite sides, but we do have some like terms on the same side, yes? 12 minus 3. And 12 minus 3 is 3x squared. Positive 9. Because we're taking 3 away from 12. If I take 2 away, I get to 10. Take 1 more, and we get to 9. Well, we still have quadratic terms, yes? So we need to get this equal to 0. Now with this here, I would move our quadratic, the x squared term, first. Because here, we're going to subtract 3x squared from both sides, and 4x squared minus 3x squared is almost, it would be x squared, because our 4 minus 3 would be 1, so we're left with x squared. Now, part of the reason I say that is if, so I'm going to erase something and change the value here. Because if we said that this had been, say, 4x squared, I subtract 4x squared from both sides, well, the x squared term is now gone, yes? Do I still need to get it equal to 0? No, we can get x by itself and solve from there. So sometimes it's nice to move the x squared term first, because if we move it first and it turns out that it cancels out completely, then we're going to solve it a little bit differently. The same thing has been true if it the 3x, the middle term, it canceled out completely. We can solve it by the square root method. Get x squared by itself, square root both sides. But here, it did not. So what can we do next? Subtract 9 from both sides. Telling us that we have x squared. 10 is equal to 0. How do we want to solve this here? We can graph it. Is it likely that we'll have a fractional answer? I'm going to look at the previous page. So we did have one fractional answer, yes? Well, the fraction part came from the number being in front of x, yes? And the reason we had a number in front of x is because we had a number in front of x squared, yes? So if we look at this problem, where we're at, do we have a number in front of x squared? So is it likely that we'll have a fractional answer? No, because if it's rational and there's no number in front of x squared, the likelihood that we'll have a fractional solution is very low. We do have it crossing at 2 places, and those 2 places are -2 and 5. Because if there is no value, well, if the value of a is different than 1, we'll have a rational solution. There's a good chance. If the value of a is 1, the only way we'll have a fractional answer is if it's irrational or imaginary. Then we're going to possibility of that there. But if a is 1, the likelihood is very slim. So -2 and 5. Questions on this here? All right, we're going to do one more today. Not too much, but this is about where we've gotten with the other classes. Now, out of these three denominators here, the middle one will factor. And what will it factor to? Yes, it's 3. Because for x plus 9 and x minus 9, it would need to be x squared minus 81 to start with. Restrictions. So x minus 3 and x plus 3, and yes, we will get there. Now, even though they do show up more than once, we only need to list the restriction once. Here, we can add 3 to both sides, telling us if x is 3, we do get a denominator of 0, so x cannot be 3. And the other one we can subtract 3 from both sides. So x cannot be positive or negative 3. If we get one of those as a solution, we're going to cancel it out or cross it out because it would be an extraneous solution. It doesn't work. Questions on this here? Now, what do we need to multiply everything by? So we can start off with x plus 3 and x minus 3. And see if we need anything else. Because in the first expression, the x minus 3 would cancel. Our middle term, the x minus 3 would cancel. X plus 3 would cancel. And our last one, x plus 3 and x plus 3 would cancel. And that does reduce out every denominator, leaving us with 6 times x plus 3 is equal to 8x squared times nothing. There wasn't anything left over. Minus x minus 3, yes. Questions on how we got to this point here? Now at this point here, we can distribute the 6. 6 times x is 6 times 3 is plus 18 is equal to 8x squared. Now we're going to do negative 4x times x, which is negative 4x squared. And negative 4x times negative 3 is plus 12x. Well, before we start moving anything across the equal sign, we might need to combine our like terms. 8x squared minus 4x squared is 4x squared plus 12x. Well, here we have all the like terms combined. We have everything simplified. So we need to either move everything from the right to the left or left to the right. And I would go from the left to the right. Now, the amount of stuff we have to move is still 2. We're still moving 2 things either way. But I want to try to keep this x squared term positive, if at all possible. So we could subtract 6x from both sides. So this 18 is equal to 4x squared plus 6x. Yes. Now we will minus 18 from both sides, telling us that 0 is equal to 4x squared plus 6x minus 18. Is it likely that we'll have a fractional answer?
Yeah.
Yeah.
There's a 4 in front of the x.
Because there's a 4 in front of the x squared. So there's a good chance that there is a fractional answer. Now, is there a greatest common factor between these 3 terms? 2. So we can divide that 2 out, since it's just a constant term. Telling us 0 is equal to x squared plus 3x minus 9. So even though it did reduce, we still have a number in front of x squared. So we can graph it, and we might be able to get a solution, but it won't give us both. So we might as well go to factoring. We can. It will probably, as I did it earlier today, it will give us one of the two. So we'd have to come back and factor it anyways, if it is factorable, and it is. Since the third term is negative, our signs are opposite. Factors of 2x squared are x and x, 2 and 1. Where do we want to put the 2? First one. Factors of 9 are 1 and 9 or 3 and 3. Take a guess. 3 and 3. Now we can check this here just to make sure. 2x times negative 3 is negative 6x. 3 times x is plus 3x, giving us negative 3x. Correct number, but wrong sign, so we need to switch the signs. All right, guys. 2x times 3 is now 6x. Negative 3 times x is negative 3x, giving us a middle term of 3x that we wanted. So we have it factored. And it's also telling us that two things are being multiplied together to equal 0. So one of them must be 0. Now if we start with our 2x minus 3, we can add 3 to both sides, telling us 2x is equal to 3. Divide by 2, x is equal to 3/2. So that's one of our solutions. All right. For the other one, we can subtract 3 from both sides, telling us x is equal to negative 3. It does not matter if we put the 1 in front of the x, because 1 times x and x are understood to be the same. Are either one of these a restriction? Yes. Because what were our restrictions? X cannot be positive or negative 3. So since negative 3 showed up as a solution, we're just going to cross it out. We're going to remove it. So the only solution for this here is 3 over 2, our 3/2. That's the only one that actually works back in the original problem. Questions on this here?